is the Amp Hour Podcast, recorded September 9th, 2012. Episode 112, with guest Bob Simpson, Ardent, Automotive, Artisan.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Chip Report TV and Chris Gamble's Analog Life.
And I'm Bob Simpson, of the founder and CTO of EV Drive, a young startup company here that makes and designs EV electric vehicle drive systems and components.
And conversions, right? And you guys convert all manner of cars.
That we're actually, at the moment, we're mainly focused on conversions, just for the sake of taking a really good design, whether it's a motorcycle or a car, and making it even better, as we put it.
I like that.
Thanks for joining us, Bob.
You betcha. Happy to.
Have you seen the documentary Revenge of the Electric Car?
I have indeed.
What do you think of the whole Tesla Roadster thing? You know, on the brink of bankruptcy, and
it was just a great story, and it was funny because I actually went to a screening of that and had my BMW on display.
Oh, nice.
At the screening here downtown Portland. But the interesting thing is that as they were going through that first part of the movie was exactly synchronized with me and this BMW starting that build, it turns out. So this was part of actually my story, believe it or not. So more on that later.
Oh, okay. Well, so you mentioned a BMW. Can you tell us about your about that build? I mean, and maybe what got you started in this whole thing?
Oh yeah. Well, in that case, I'll just mention it right now. I mean, Tesla had a role in my start of this project. It turns out, the middle of 2007, I was just settling down. My last little projects, a snow drive system in my off-road dirt bike, and I was thinking about a new project, and Tesla had just come on the scene and had some white papers they were talking about in a technical world, and I jumped on that concept quickly and followed it for a couple of months and realized this is my next project. So I methodically went through the thought process of, well, as an engineer, as a career engineer, what are the biggest issues to do this? And they were answering really what they were, and that was batteries and motors. That really got me thinking about this. But before I really had the full confidence on the batteries and such, I wanted to prove it myself, and not just go on hearsay, because there wasn't a lot of information about this at that time on the web, really, about lithium batteries of any
and
kind.
And roughly what time frame was this? I mean, was this...
This was mid to late 2007. Okay. So September 2007 is when I actually pulled the gas engine out of my BMW to make this conversion.
That's pretty
perfectly
gutsy.
Good.
Yeah,
it is.
As somebody who rarely even opens the bonnet, let alone... yeah.
It just so happens that my convergence of a number of experiences allowed me to have the confidence to even consider such a big project. If you can imagine, I couldn't really tell how it was going to go until I had all that stuff out of the way. So here I'm taking a perfectly good, young, working sports car that looks like it's right off the showroom floor, and I'm disabling it drastically. But I, at that moment, I knew, that gas engine is not going back in.
Yeah.
I'm going to figure this out, period. And so, again, because of all these experiences in my past, my brother and I have been wrenching on cars and motorcycles for so long and racing motocross through the 80s and 90s. All this stuff came together really quite abruptly, and I saw the light basically triggered from Tesla. So that was really kind of the start of the whole thing.
That's great.
What did the wife think? I assume you're married?
I am married, and she was actually She's used to these kind of projects, although not this big.
Having a furnace on the front lawn, that kind of thing.
Yeah, right.
That's right. The interesting thing about her role here is she, of all things, was the one that ratcheted me up on the choice of the car.
Really?
I had been thinking about for a week or two and bouncing ideas back and forth with a buddy of mine and about the choice of the car, and I landed on the BMW 325 as just the perfect middle zone, not too big, not too small, pretty aerodynamic, a good handling machine, and I thought I know I can produce that same handling if I replace the gas engine with an equivalent weight and location of its weight, drive package. Well, so as I was looking for a chassis, I came across this one that was essentially looked like a showroom unit that was very young, low miles, driven by a lady that only drove it on nice days, basically, and never even had that spare tire out of the trunk or people even sit in the back. And so I kind of sheepishly pointed it out to my wife, and she says, well, you'd probably be a lot better off spending your time on what you want to do with it instead of fixing it up, and you're going to have it a long time. You might as well get a good one. So she basically twisted my arm, and I jumped right into this really perfectly good car.
Great.
Instead of a fix-up. So that was really quite a breakthrough, really, and it really enabled me to really just keep my focus on the top-down conversion pieces instead of cleaning it up and all that stuff. So that was pretty strategic. But just prior to that, there is one more thread I should mention about what got me into the car with confidence, and there was a little previous step, it turns out, that I took. My motocross brother and I had such a passion for motocross. I thought, well, there's one way to really prove the performance of batteries is to do a little motocross project. Just if we could possibly get the kind of performance out of it with that scale, then that would be really good to prove the battery technology.
Got it.
Well, it just so happened that it was the perfect project. It was only 176 A123 cells that I actually got via DeWalt tool. In fact, it was Black & Decker that hot shipped me a whole box just full of those that I immediately took apart and put the cells in. And then, of course, I realized, well, I had to focus on, well, how do I put these cells together in a compact and high current sort of way? And so, of course, I immediately had to step into that world. I ended up spending $12,000 on a custom welder right out of the chute. I got off eBay. And thinking, okay, I'm going to get serious about this. I've got to do this right. There's no other way. I'm going to get this very special welder that actually has a data acquisition feedback path that has a real-time delivery of energy with the shape of a waveform that I described.
You
well, that's
nerdy
the ultimate.
engineer, you.
It is. What can I say? I knew what I really needed to do, and it was just a matter of, okay, I had the incentive now to do this right, because we could potentially have a dirt bike that we could ride that's just full electric that doesn't have any performance compromise. That was kind of what was in my mind. And it's like I was just thinking, this has got to be possible. This is the way to prove it. And so it was a fairly scaled down project, off the shelf DC motor controllers from Ultrax and Perm DC motors, but not just one of them, two of them, because they fit.
Gilding the lily, as Dave says.
Exactly. So it was just all motor. Okay, there's just a little bit of space for batteries where the gas tank used to be, and in the airbox, a few more cells, and a little bit amount around those two motors. There was a little notch that I could put a few more cells in. So we ended up packing in 176 cells, which was not a very big pack, 1.3 kilowatt hours of energy. However, that pack can deliver about 90 horsepower worth of energy per its spec. Wow. And so that was where I realized, if this is real, this could actually deliver full performance. And the motors, by the way, if they truly deliver what they claim they can in torque, this is going to be a handful of power. And you put two of those in a really light frame.
And now we put it between our legs.
And it's a coffin on wheels, right?
Yeah, well, for a motocrosser, that's what this is all about. Just raw horsepower between your legs. And guess what? It turned out. It proved it full tilt, and we were happy to confirm that the whole thing, the numbers were right. the specs on the cells and the motors were not exaggerated, and we're getting lots of miles logged on that machine even today. It's during the drive weather, that is. I get lots of use shuttling between my shops here, it turns out, just because I can. I can just throw a leg over that thing and flip a switch, and even if I can carry something in one hand and only twist the throttle with my right hand. I don't need two hands to ride it. Set things in my lap and scoot down there and then throw a leg off, and I don't have to spend so much time walking.
Is it single gear? Is that why you can do it with one?
It's single gearing. No,
wow.
Nothing to do with your left hand or your feet. I mean, you can use the rear brake with your right foot.
Yeah.
So it's very just you flip a switch with your finger and just lean forward and roll her on. So
these are the same cells used in the Tesla, are they?
Not exactly. These are higher power density cells with lower energy density. The cells the Tesla is using are literally the laptop cells.
They're the 18650s.
They're the 18650s, and they're made more for energy than they are power, but they have enough of them that gives you the power that you need to push that light machine around like they do. So these ones are 26650s, the original A123s, and their power density was very, very high out of the chute. And they were basically the ones that kind of set the precedence on that power level, really, that power density. Yep. And since then, there's been some even bigger things done, but they started it.
What are you shooting for in a pack like this? Are you shooting for a higher voltage pack, or are you shooting for a lower voltage, massively paralleled pack?
I generally focus on the higher voltage packs, and I'm not afraid of the voltage at all. It's anytime you get above 100 volts or 200 volts, it's dangerous. And so whether you're 350 or 700 doesn't really matter to me. I mean, there's a little bit more BMS resources consumed at the higher voltage because you just have more cells to monitor. But there's a very strong relationship in voltage and AC motor drives, it turns out. And to deliver raw horsepower, voltage is king, it turns out. So that's the focus of ours.
Why is that? Less I-squared-R copper losses? Or
it's not just that, but it has to do with a lot of the math in the drive system. And to be honest, I can't succinctly nail it down to something very specific, but I know it has to do with that. There's a square root of 2 in the equation for motor voltage, and a square root of 3 in the calculation of the AC power out of the inverter with a 3-phase sinusoid drive system, and it's kind of complicated. You can kind of roughly estimate by saying, well, you're drawing this much power off the pack and delivering this much voltage and this much current and this much power, but it's not really that easy, it turns out. There's some other factors in there, but you can approximate it that way, minus 10 or 20%.
How do you integrate a battery management system, BMS as you called it, into these sort of things? I mean, you've got how many cells? Like hundreds of cells.
In the original BMW pack I built for the 700-volt Siemens drive system, it was 204 cells in series, and each of those...
And they're all each individually monitored.
And every one of those are individually monitored and controlled.
Ouch.
Yep.
Wow.
Well, so I just made a highly redundant little microprocessor that lived its life off of every cell. So there's a processor for every one of those living its life off of in their own little voltage world, and then optically talk to them.
Oh, I was going to say, how do you transfer? Optically is the go.
Yep. So everything is very
bunch of
localized.
So each cell would have a little microcontroller, I presume, using the built-in ADC and a voltage reference, and then an optocoupler to shoot the serial data out.
Exactly. And
204 of those.
And if you can actually do that with the means of shutting off the power at 2 different levels, what I do is I have a switch that the processor can turn off external hardware that involves the shunting process. And just their power supplies go off, and then you can take the next level down and shut the processor down, make it go to sleep, and go into basically the nanoamps. So, an important part of the BMS is how do you do it without leakage, basically. Minimize your leakage for the circuit that's living its life on that cell. It's not really that critical if you're using something daily, but if it's sat for months, that's
Sure.
very problematic. And so it's a very important aspect to have that minimize that leakage. And that's part of my focus was isolation and low current leakage and flexibility. So I actually
The speed, I'm sure, right?
actually put in one last little detail. I put in a control circuit that allowed me to do any shunting with a MOSFET device rather than just a fixed resistor.
Right.
And in hindsight, that's a little bit overkill. But it was an unknown at the time. Nobody had done this before in the public domain, and I blue skied the whole thing, and I just put all the resources on it that I figured I needed, and it's working actually. There's a machine down in New Zealand, a little car that's been happily running around for the last several years with that code in it, and my BMS working quite well, but. So anyway,
did you design this all yourself? Is this all you?
I did, yeah. They're really. I looked around for something at the time, in late 2007, early 2008. There really wasn't anything to buy off the shelf. There's, of course, designs that companies had that were proprietary. They just weren't, up for sale or on the web visibly in any way that I could find. And so I just had to blue sky the whole thing. But I did have some previous experience while at Tektronix with battery management and DC-DC switching power supply design and a variety of things involving batteries here later in years at Tech. And then, of course, became even more so when I got into the batteries, the level I am now, that I became the tech kind of battery go-to guy for a while there.
Yeah, you're the man, huh?
Now, I'm curious, how did you get the couple of hundred pairs out of the pack? I assume that it wasn't like a shared bus multi-drop communication interface. Did you get a separate pair out for each cell? Back to one main controller that monitored? How did you physically implement the interface from a couple of hundred sensors?
That's a very important point in this whole thing is how do you get access to these things practically without creating spaghetti that would be a fire hazard,
Right.
or
That's right.
or
Multiple
you add
lines per
fuses to
drop.
them, and now you've added more cost and more connections, and everything just grows exponentially.
Oh, nightmare.
So it turns out I laid in bed for quite a few evenings back then thinking about, well, how do you do that? And the epiphanies popped out, several times while doing this multi-engineering while trying to sleep at night. And it just so happens that kind of the answer was modules, a modularity level that found the happy mix, but with the core element, the core concept having everything local with the cells. So as close as you can get the electronics to the cells and then connect over a controlled communication interface for the distances. That was the basic form that I started with. So, and then physically, what I did, because of the actual shape of the volume I had available under the hood to choose from, or to use, I should say, for cells, it was a variable depth bottom. So that together then gave me the idea of making these modules that slide in vertically of different lengths that and different positions have different lengths, and it makes a 3D bottom that utilizes this weird shape under the hood, and but brings them all up to the top surface as close as I get underneath the hood surface, and those ended up being little modules that were 5 modules wide and 6 deep, and they varied from 10 cells deep to 5 cells deep, and each cell is actually a group of 10 of those little A123s in a 2x5 arrangement. So one cell is really 10, but they're hard welded together in a single continuous nickel sheet, not individual tabs and series. It's a solid square area. I focused on the current delivery out of these really good cells right out of the chute. So the motorcycle and the BMW have a neck width of nothing less than about 5 inches. It turns out, of width of this of this nickel sheet of certain thickness that then gives me a very, very high current delivery. Then in that is water jet cut the images around each cell where I do the special welding, and I have to shape that to steer the current, to literally get the current in between the nickel and the cell's plates, so that the little molten ball is just centered. And that's kind of a whole nother story. But so once I figured that out, that process, then I can do any battery shape, and welding them up with these really wide plates then gave me the ability to take the input on a module on the top and the output on the module on the bottom, stick FR4 sheet between them, and run them right next to together without any air gap. So there's no air spaces inside any of these modules other than in the little cylindrical shapes of the 26650 cells, of course, have air space in there. That's just the way that is. Everything else...
Run peg, square hole.
That's right, exactly. Everything else is completely down to... no airspace. I mean, the thickness ended up being maybe 25 thousandths beyond the length of the cells themselves. Well, that's what it took to fit 5 rows across with the cells in a particular situation, and it literally left 1/8 of an inch on each side of the pack to the chassis. Well, that 1/8 of an inch, I figured that's okay. It's an 1/8. It's not 0. It's an 1/8. And I made it float, so it's all mounted on rubber. And the whole pack allows the chassis to twist and move with the road without imparting any forces into this cubic chassis.
Nice.
And as long as it doesn't touch any metal around, you're good, right? Well, an 1/8 of an inch was more than enough, it turns out. And I have even less than that on top, and a little more than that on the bottom, depending on where it is, but tight fitting, and it fits as long as everything is accounted for.
Wow!
And that's where all the black magic
goes.
Yeah.
In. So
that's an incredible amount of engineering just on the battery pack.
It was really quite a leap just to get the mechanics to allow the electronics to get that intimate location with the cells. And so I literally took this very compact board layout, which I had done lots of at Tech, with very tight stuff, sometimes in little probes that have just packed full of stuff like crazy. That makes this really easy, actually. So I make them very, very small, as tightly as I can, fit them right into the profile of the cells in that same module that was formed to fit that under the hood. And if I figured if I can get the circuitry in there in the top profile of those modules, then this will all work, and I'll have all the access to the cells vertically. So every module, being vertical, then had a ribbon cable that plugged into a long row of pins on the board for sensing voltage in one path, for shunting voltage in another path, and individually, so they don't share current and mess up your voltage reference. And then thirdly, the actual device that's dissipating the heat down another group of pins that all goes down the back of the cells inside to then peels off all the way down through the cells. Well, to get to the electrodes on the other side of the cells, I just simply had water jet holes in the middle of those sheets strategically put so I could pass them through the little voids between cells to the other sheet, the other side, and everything then got completely embedded. Every cell has a temperature sensor on it. When I say every cell, it's every group of cells has a temperature sensor, so there's the same data for all 204 cells in voltage down to a few millivolts of resolution and temperature, and then the controllability of shunting. But the shunting is now at the bottom of these modules with a board that has lots of little vias that carry heat from the MOSFET on the top of the board that's really embedded in the foot that pushes the heat through all those vias into the base that's a solid copper sheet that's then thermally laying over a high voltage thermal isolation boundary that then lands on a aluminum base plate that actually has liquid cooling in the bottom.
Okay. I was going to ask about
how hot do
heat,
these packs get during full operation, like full, you're flooring the car or you're flooring the bike? How hot do these packs get?
Very good point. it turns out the car, I barely heat up the cells no matter how hard I drive it. I can just barely get a thermal rise out of the cells under hard
so the
use.
internal ESR is that low.
Internal ESR is that low, and in the case of the BMW, there's so much parallelism. I can actually.
Does that mean the battery pack's overkill?
It is. It's overkill in terms of its current capacity, but it's not overkill in terms of its energy capacity. Of course, you want more of that.
Yes. So, of course, you want that, and you want the lowest ESR possible. You don't want to be pissing away power in the internal ESR as heat in the battery.
Exactly.
You want that to go to the motor.
The lower the impedance of every element in the system, the batteries are a strategic part of that. The inverter's the same thing. There's a drop across those MOSFETs where they're turned on. I mean, it's small. Yep. Well, they're all a percentage. Turns out the inverter is a 2% loss under full power. The batteries are in that area, maybe 3%.
How do you get it? So that's 98% efficiency.
Yes, 98% efficient.
So, you can design 98% efficient DC to DC converters, but it's usually over very narrow load range.
Well, in this case, this is specialized as a power delivery stage with very intimate liquid cooling, and literally the impedance is so low that that is the result. These things are heavily characterized, and they're 98% efficient. And as far as over what full load range that 98% applies to, I guess I'm not totally certain. But this is a tried and true machine from a company that's now kind of set a reference here in the planet, Reinhardt Motion Systems, who happens to be, I'm very tight with the key engineers and the owner. Now, they actually sponsored me originally when I had trouble with my original inverter that was supposed to be driving my Siemens that never materialized from a startup in Europe that ran out of money debugging their code, turns out.
Oh, no.
So anyway, it turns out that it just happens that a much more compact and more thoughtful and shaken out and proven automotive design here with all the proper margins. Very, very good design in every way. Done right here in my neighborhood of all things, Reinhardt Motion Systems.
Nice.
So it was.
So you said it's actually cooled by liquid. It's liquid cooled. Is that like in a regular car? Is it like a sealed circulatory fluid cooling system?
Ethylene
right,
glycol
so there
based.
are mechanical things that can go wrong there.
There's really nothing mechanical in that. It's just fluid passing through pathways in this inverter.
But they can leak. And if your fluid, if your coolant fluid leaks out, just like it does in my car every 6 months.
Yeah, in which case you would immediately have the inverter back the current off to prevent any damage to the drive system.
Oh, yeah, of course.
Yep.
But that would be a maintenance issue.
That would be.
I thought the holy grail of electric cars was that the fact that they didn't have anything like this to maintain. All you had to do was, I don't know, tighten the wheel nuts every so often.
Well, there's always some maintenance. You have bearings that you're rolling on. And of course, those are, and this is really similar to that. This is just passing fluid through. So there's really no wear per se, but there is an opportunity for, a hose to come off, somehow or another. But that's really a very small issue in the big scheme of things, because we can do that very reliably these days. And in fact, if you just go to braided steel, like we're doing on our performance off-road machine contract that we're working on, for example, well, then you just make it bulletproof. If it's mission critical, you can make it mission critical. Right. Absolutely. So it's really, that's a trivial detail, in the big scheme of things. But I mean, that's true. Technically there are some things that could stop the show, and a wire could come off too. There's still interconnects. So this drive system basically forces you to work out the interconnect impedances, and the physical nature of delivering this much current becomes an important part of this whole design. So no one person really could do all this. So I did the whole vehicle. The BMW was completely a solo project in terms of me designing and fitting all my stuff into it, but I stopped short of the motor and the inverter part. I could only choose my battles, to a certain point, and those are battles I couldn't do simultaneously. There's just no way. So it just so happens that these guys have the expertise to do what it takes, and they're delivering units now into the Ferrari. They've been doing the Ferrari systems for several years. The KERS, the kinetic energy recovery systems, they were the ones that did the inverter for that they've been running for several years now, and probably 400 up to date now in machines around the world. That lots of big names of electric vehicles that you've heard about in the news, high performance, are these drives basically.
Bob, can you give us a some reference points here in terms of impedance? I mean, you said very, very low, but what is very, very low for you?
Well,
that allows you to get to the 98%.
Okay, the way to describe that is how much current it can deliver within this 2% spec. So right now a PM150 inverter, for example, can deliver 300 amps at in the 600 volt environment. So 200 horsepower is what you can deliver out of this thing.
300 amps to 600 volts.
Yep. And that's RMS. That's RMS, and that's continuous current it can deliver, by the way. And
use Ohm's law there, folks.
That's a lot of energy, continuously. So in a vehicle, that's just extremely. You can't draw that kind of power longer than a few seconds. Otherwise, you lose your license, or you're on a racetrack, and in which case you can sustain a part of that until you get to the turns, and you have to back off. And so it's literally, that level of power. Everything in the system is designed appropriately. You don't just use off-the-shelf components anymore for connecting these things up, and so really this is really a full system kind of thing. And I'm happy to say that my partners with the motors, taking the state-of-the-art REMI cores. This is REMI of Delco REMI, as everybody knows them, but without the Delco part. They're the ones making many of the core elements that are going into the transmissions in the vehicles being sold by the big auto companies. And we take those cores and put our own housing around them, all liquid cooled with internal oil pumping that uses literally oil pumps out of motorcycles that are built in, and the shaft that the output shaft also spins its own pump and self cools. It's not used for lubrication. There isn't any lubrication needed. It's just for cooling. So it lives its life in clean, cool oil for its whole life, which will outlast our human lifetime in these motors, it turns out.
But I'm still disappointed. Electric cars, I don't want oil, damn it. I don't want coolant fluid. I just want
this is one of those small compromises. I mean, after all, there are some compromises, based on just the laws of physics. And right now, the fact that we can only get 90 miles of pure electric range, at least in my BMW as it is right now, and there's times I need to go past that. I need to go out of town, and I'm on the verge of actually now doing that, having added gas back into my vehicle, something I never thought I would ever really do.
This was a question I had. What do you think about the the Chevy Volt, for example? Is that the ideal electric car at the moment because it fulfills everyone's requirement for the long range instant refill, but it also has the EV option?
Yeah, Bob just developed a new part of his system, right?
That's right. It is the correct approach, but it's a half step there in the case of the Chevy Volt. But in a relative sense, if you're comparing, what's out there on the market, between that and the Fisker are the two cars that you can get. Both range and electric drive out of. But, and now you compromise. They've only did a 40-mile range or 35-mile range. But it depends on your daily
But that's
commute.
good enough for the average person, isn't it?
It is.
That is the length of the average daily commute.
Absolutely.
Yes.
And I know several people now that own them and have been driving them happily, and they just love them. And so my first question every time I see them, how many miles, how many gallons of gasoline have you burned so far, and how many miles have you driven? And it is incredible.
Nice.
I mean, the miles are in the thousands, and the gallons are in less than fingers in your hand. I mean, it's incredible. Wow. It's in fact, one case I think he was at 4,000 miles, and he had burned 2.5 gallons of gasoline. And so,
and you have to do that occasionally because it's got to,
mileage.
even if you use fully electric, it's got to start up the motor once a month just to keep the everything lubricated. And,
Sure, wouldn't hurt. Run it for a few minutes every now and then. If it comes down to that, that's a good problem to have. But it really becomes, an enabler for the electric drive part of it. And in my situation, I've got this really nice machine I just love to drive, and if I don't have the time to be able to charge for a distance I'm going, or it's out of my range, et cetera, and I'm not able to plug in while I'm there, then I have to reluctantly take my Honda Civic that burns gas every single mile of the way. So the way I see this, that adding gas to this thing allows me to use more of my own energy. And in this case, when I say my own energy, I really mean it. I'm creating my own energy. In fact, I'm creating more than I'm driving a year. And
the sun's making the energy, right, Bob?
I'm actually collecting that sun personally, I guess. So when I say mine, I guess I'm assuming when it lands on my roof, it's mine.
Yes,
and so
I claim this in the name of Simpsonia.
Exactly.
So tell us about your home system. I mean, you have cells in your house.
Do.
Is that right?
So on the top of my roof, it's hard to even see it. We have a 2-story house, and we're kind of on a slope, and so as the roof slopes away, so does the ground. It's hard to even see it unless you get far enough away. But it's flat on the roof, so it's very non-visible. Other than it's pointing right at the sun, and it had a good angle, this 18-degree angle. So it turns out that we were able to get officially the system incentive from the Oregon Energy Trust that paid about a third of the cost, and then the state and federal paid another about a little over that third. And what was left was $4,300 out-of-pocket expenses. And we used this company called Sunrun. Very good deal. A contract that they're responsible for all the equipment for 20 years. I can buy it off of them anytime I want. In 5 or 10 years, I'll say, I'll give you $1,000 for it or $500 for it, and then it'll just be mine. Right now, it's actually transferable even, although I don't plan on it, but I could take it with me if I moved, or leave it and transfer it to a new homeowner and keep it tied into the grid. It's all stuff that has to be permitted and everything, and so it's a very shaken out system now. And so I just had my milestone 2 weeks ago of a first full year of solar power, and I have all my stats now. So it was a phenomenal result. It turns out I got 18,400 miles of driving that BMW worth of power. Wow! So I only actually used probably 8,000 miles, about what I drove the Beamer this last year. The power, though, overall went into the grid during peak time. Obviously, that's when the sun is shining, and the more the sun is shining, the more the air conditioners are on, the more demand there is, the more I'm poured onto the grid, basically. It turns out that the other key fun fact is I put 1.4 megawatt hours of energy back onto the grid with this system. In other words, during the time of day when our house was not drawing very much and we were spinning the needle backwards, the 1.4 megawatt hours is what we accumulated in our account that we put actually onto the grid. Often the power is going into our own stuff. In fact, there's many times where it's during the day, I'll come home and I know I'm going to go out for another drive. I'll plug my Beamer right in while the sun is shining. The needle is still spinning backwards and it's doing a full charge on my BMW. Wow. So my energy is going straight to the BMW at that time. But normally I just get it late at night rather than during the day, and with time of use you can actually make money on your own power. So you create that power, and I make 2-to-1 ratio of money off of it. I buy it back for half the cost they have to sell it to me for.
I didn't know you had so much sun in Portland.
Well,
I was going to say.
Sorry, Northern.
It is amazingly a lot amount of solar, and they guaranteed 4.8 megawatt hours of energy off of this panel, and it turns out I got 5.26 megawatt hours off of it. It's real power. It really is. And in fact, now our power bills are astonishing. During these really good sunny summer months, which we finally got sun. We had a really long winter this year, but when the sun turned here in July, in August, we got some incredible sun to the point where I'm getting 90 miles of driving a day average right now. but we're at the point now where we've pushed our power bill, our house power bills, down to less than a third of what they were last year during the summer months.
Wow.
Nice.
So, in fact, I just got our power bill yesterday. It looks like it's below a quarter now. We're at 16 versus 60 last year in terms of our kilowatt hours consumed per day on the average. So, it's an incredible impact on just our power consumption as a whole. So, not only am I driving for free with that Beamer, I'm also paying down our house power bill by that much, and that's where my payback is on the energy that I don't drive with. Now, the driving itself, I'm displacing gas, right? Well, I've actually in my presentations I have diagrams that are actually a graph that shows the very specifics with gas and with electricity and then with solar, and it's pretty phenomenal the steps it transitions, going from driving with gas to then driving with flat rate electricity to then driving with time of use and solar. It comes down to, believe it or not, it comes out to 1.7 cents per mile that I make profit off of the system if I'm
Nice.
tying that solar system to my BMW, which I'm doing explicitly. That's what I'm making off it. Well, that 1.7 cents per mile, that pays for my only real wear item, which is tires in that car. That more than covers the tires that literally that I'm wearing.
Wow.
And so,
Now, this all sounds very utopian, right? Have you done any research, though, into, playing devil's advocate here, into research of how all of this stuff affects the planet globally, like the manufacture of the solar cells, the manufacture of the batteries, all that lithium, all that, because I've read stuff that says, well, local solar cells are the most inefficient solution. So if everyone on the planet had local solar cells on their roof, that's a horrible way to do it.
Yeah, I've heard those arguments.
As much as we personally love it,
right.
that is not the ideal solution. Have you done it? Have you looked into the economics and the philosophy behind all that?
Yes, I have. Now, there's the part I haven't done is actually like sanction a study or found some independent study about truly doing the solar PV analysis to that level.
Yeah.
My gut feeling says that that's a bogus statement. I believe quite sincerely that just based on my experience of all this stuff in my history, that the life of those solar cells will more than make up for the energy consumed that would have caused global warming or some such thing. And I do have something that I have dug very deep on that I would love to talk about, and that has to do with power sources. So it turns out that I look at things at the system level. The BMW is this electric drive system is a system in itself, as you know, that all the components, very much a system orientated design. That the batteries and their current delivery match the demands. I mean, everything about it is a system kind of thought. Well, you take the next step up, which is now the car is part of the next level system, and that includes the power sources and the grid.
Of course.
Of course. And a big part of that is, okay, well, what's feeding the grid, So initially when I was demonstrating my bike at shows and car to people, I would always get people that step forward and say, well, you're burning coal,
burning fossil fuels,
and you're worsening global warming, which people that said that don't believe that humans are affecting the planet at all. And so they're using that against you anyway. But so it turns out that I was asked so many times very early on that. I have a really good engineer friend at Tektronix that took on a special project for me. No money exchanged hands. It was just, I'm curious, and can we find this out? He set off on a little study using a big spreadsheet system where he filled in every box of energy consumed and what it was and how much CO2 was related to harvesting coal and putting it onto the grid versus driving the same car, the same route and distance as the original machine had with a gallon of gasoline. And so what this study did was it compared 1 gallon of gasoline, 19.2 pounds of CO2, created from that gallon. That's where I stopped the study in terms of the gas side of the CO2 side, just for a reference point, okay?
Right.
But we took the diesel burn to use the hopper to pick up the blasted coal, to load it in the hopper that brings it to this place that burns it, and then chemically gets the power and delivers it to the house. And literally coming into my garage at 7.5% a loss to get it to me, and everything factored in, including 10% of the heat loss to get my charger loss to get it into chemical storage in my BMW that I drive with. So now I know exactly how many miles I get per kilowatt hour that I take off the grid, which happens to be 3.5, exactly 3.5 miles per kilowatt hour. Well, so anyway, so back to this thread of this power, the source of power. The coal study, without any looking at the numbers ahead of time, finally boiled down after several months of gathering the data from the mining and all the stats that he could.
Wow, he went like
all the way,
huh?
all the way, and then it came down to the bottom line. Then did the summation, so to speak, at the bottom. And the number turned out to be 27% less CO2 produced if 100% of the energy that I drive with came from coal put onto the power grid.
Really?
Right.
Okay, and that just considers 1 gallon of gasoline by
Compared to
itself.
gas. Wow, that's...
So then you take that, and then, by the way, this dovetails very well with other people around the world that have done the same study. We all landed on the 30% zone with that sort of an approach. There was another group here, PGE, a guy that works at PGE, our power utility here in Portland, that was giving a presentation, and he put out the stats to be 50 to 60% less CO2 produced when everything was included, not just the gallon of gasoline, but then
manufacturing the lithium for the batteries and the whole...
Okay, now that part of it...
Because that's the tricky bit, because you have to dispose of those every, 5-7 years or something, and you've got to manufacture them very late.
Absolutely. So that side of the story now is that you do have to mine that lithium the initial time. It turns out that right now, the recycling part of it, we can get right at 95% of the lithium recovered from the recycling down there at the site in Texaco, in Texas, but from Toxico, it turns out is their name, and they pull that much lithium out of it. Very efficient recovery of lithium. Okay, so it's kind of a one-shot deal. You get it out, you get 2 lifetimes out of that. One lifetime is the active use of the cell, and the 80% level is considered the first lifetime. So in an EV, when you lose 20%, that's considered a full life usage. And depending on how you use them in a vehicle, that'll be 5 years, it could be 8 years, it could be 10 years, and it comes down to the cell stress and temperature and the management. If things are more conservative, if you do like the big auto manufacturers do with hybrids, they're very, very conservative with the depth of discharge in the batteries. They go centered 50% point plus or minus 20%. That's how you get hundreds of thousands of cycles out of nickel metal hydride. If you did full discharge cycles out of nickel metal hydride, far, far less than that. In fact, less than lithium ion. So this is part of the equation is that if you get down, you're using 80% of that, and you always keep margin at the ends, and the temperature is not rising every time you drive it hard in the summer and go down the freeway at full speed. It doesn't make them cook like the past generations have done, and I can speak from experience with that, with a Toyota RAV electric with nickel metal hydride cells.
Right.
It's so transformational because of, again, the impedance, that the heat is so low that the degradation is lower and lower. The initial wave of lithium cells are not that long life because they're only rated at about 300 to 400 cycles. And they're good energy dense cells, but they're not really meant for longevity. Those are going in products that are sold by the billions around the planet that get thrown away every other year, kind of thing, literally.
That's right.
So camcorders and handsets,
mobile phones and everything else.
And that's just part of that business. They don't have to last very long. Well, now that they're being designed in a different scale of energy and longevity, there's a whole different set of design requirements, and things are changing drastically in that regards. There's attention to the detail mechanically, chemically, electrically, all now together as a system design at that level, and so there's been some tremendous improvements in batteries. Let me tell you, over just the last several years.
Well, let's talk about that. Because really for EVs to take off, we really need an order of magnitude increase in battery capacity, right? In battery technology,
That's right.
battery
That's right.
storage technology. It's got to be like an order of magnitude, 10
even
times.
for what we have
is
right now, one half, half of that, a 5x would actually
a 5 would be
with 5x from where we have right now, and we would actually be there.
right. So where do you see that coming from, and how long?
Well, of course,
What technology is it? The new liquid metal stuff, which is getting a bit of attention.
there's a
where
lot
do you
of
think
interesting things, being talked about right now. None of it is predictable. That's kind of my take on it.
Yeah.
And so, no one in the, can absolutely say, oh, it's going to take this many years and we're going to have X. There's just no way anybody can possibly say that any more than, investing in something that's going to magically break you $1 million. So it just doesn't happen. But on the other hand, there is a shift in mindset now in a number of different dimensions. One is the scale of the design effort around the planet has gone order of magnitude larger in the last several years, and
Nice.
the mental the approaches, the several different approaches to thinking out of the box in different ways is what is really then popping out these 1.5 and 1.6 times density steps that we've got just in the last several years.
That's where I see the future is. It's got to be some out-of-the-box quantum leap. You won't get it by tweaking the manufacturing process. We just got an extra 10%
That's right.
this year, and that's not going to do
There
it.
is
It
there's
requires
another piece of that
different
that does
technology.
actually incrementally, drastically step up the reliability factor of the existing designs. And this is something that's happened the year before last. There was very large number of public announcements of companies that had figured out how to go between 5 and 10x improved with the impedance of cells.
Wow.
And what they're doing is they're embedding a more explicit conductor then intimately in with the electrode plates that actually then assist delivering the electrons such that you're not heating up the material to deliver the current out the end points. You're actually getting them into a little ductwork, so to speak, of conductors that gets it out without as much thermal. And the lower the thermal, then the less stress there is on the
course.
cells, and the longer they last. And so, again,
Are these physical
Yes.
conductors? They're not like liquid
no, these
or
are
part of the
mechanical.
electrolyte.
I guess would be a
Right.
better way of putting it.
They're mechanical, yes. that's what I
Mechanical,
was
and
getting at.
there's people that are doing kind of 3D a mesh of like organic kind of foamish like shape that is actually conducting paths that everything else is just around like normal. There's layers of like screen that are effectively like that are laid in that at the nano level.
Because that gives you greater surface area on your objects, which
you need
in
surface
turn-
area
Yep.
and conductive path combination,
Yep.
and so different techniques that people are dreaming up to do this, and so this is the other dimension. So there's the sheer magnitude of companies and countries focusing on this for obvious reasons, and the different approaches now being taken and looking at different metals and different chemistries and mixes of chemistries. Things are really starting to happen now. So it's kind of a nonlinear function in terms of the learning that's going on around the world, and not all of it's being shared, of course, but once you do get a little snippet shared, that opens up a little doorway that other people start stepping in and looking at, and then they go, gee, look what we can do with that, and so it just leverages off of each other, as long as it's not, too guarded, till the last minute, just strictly for financial gain, which of course most people do. If they see a huge economic opportunity, they'll tend to keep it quiet, and get investment going first, and then splash it out. But whatever it takes, business has to do what it does to make it happen. And this is all a matter of economy of scale. And that's the other part of the lithium battery package here as well. We didn't quite finish on the rest of the cost of the lithium source and all that, and the lifetime stuff. To finish that thread, the lifetime in an EV based on what I'm seeing right now after 3 years, I'm expecting to get 7, maybe 10 years out of my batteries that I'm using in the BMW right now. But I suspect I'll probably pull them out and put those into motorcycles because I'll be dropping in even higher power density and energy density cells to replace them and get my range up to closer to 150 miles just under the hood, and then not have any cells.
Your average punter's not going to do that, though.
What's that?
Your average punter is not going to do that. Where would you see, they're not going to want to reuse them in something. They're just going to go, take it into the shop and give me a new pack, please, because my range has dropped by 20%, and that's annoying.
So let's keep this part in perspective. This is me talking with this machine.
That's right.
And so, in terms of something more tangible to the public, it's happening from just the scale that's going up very, very non-linearly right now with all the autos going onto the market. That economy of scale is ramping up refinements in every aspect of that whole system, including what you do with the cells at the end of life. And that's part of the requirement of doing it top-down is factoring in the end-of-life stuff. So the second life of this opens up a whole new opportunity for uninterruptible power supply systems, which is a huge market as it is right now that uses almost predominantly lead acid, in some cases nickel metal hydride. But lithium-ion is by far a better choice. It's just that it's been not a good business model to go buy new lithium-ion batteries and replace your lead-acid batteries. Even though they're very poor in their life and their energy storage, it's still relatively cheap to have a room just full of lead-acid and handle your backup power as needed. Sure. But this again gives you even better performance in smaller area and longer life on its second life of the lithium-ion cells into that world. And another opportunity is grid stability, grid storage now. With the same electronics driving the cars, it's literally what hooks up to a grid and takes power in or out of batteries for stabilizing a grid as well. So that's a whole nother opportunity, although I don't see that in the near term because bigger industry is doing that with fresh designs right out of the chute, of course.
Right.
Now, I think the biggest question with EVs is the recharge time. I mean, so many people, I don't think it's so much the range. I think it's the recharge capability because people are so used to filling up their gas tank and it takes a minute or two and bang, you've got your range again.
Yep, that's right.
So that instant recharge capability of gas is, I think, its main advantage.
That's right.
So
so it just
how
so
do you
happens
see that
that's
being
changing too,
solved?
And that ties right back into our previous discussion about the properties of lithium-ion, which is so superior over anything in our past history with batteries, and that's the impedance. So with the kind of power density that we have to be a very hot sports car, you can certainly do a fast charge. And we're talking 80% charge in 15 to 20 minutes with these kind of cells.
But that's still a long time. 15 to 20 minutes is still a long time. If you're driving around and you're going to a recharge station, in quote marks,
Well, and so in this particular case, if you're changing the situation, however, because of other opportunities. Whenever you're home, you're getting power for almost free,
of course,
and so you'll do that when you can. That means you're not normally when you go to the grocery store, you don't also say, "Oh, I've got to fill up. I've been meaning to fill up."
That's why it requires a mindset change in the consumer.
That's right. That part of it does. However,
that's why I think the Chevy Volt's important because it's the best of both worlds.
Okay, so where it's naturally going right now is stores are taking advantage of that 15 or 20 minutes, it turns out. So, in fact, I just did that yesterday myself. I went to Fred Meyer and bought groceries, and I took some bottle returns back and cashed them in and picked up some socks. And I spent 40 minutes there because I was out charging for free off of their power in their parking lot with a level 2 charger. Well, right next to that was a level 3 station with 2 heads on it. 2 level 3s sitting at
what are these
grocery
different
stores now.
Levels?
Okay.
Can you explain levels?
Levels, yeah. So level 1 is a good old standard 110 outlet. You can draw about 15 amps of 110 volts AC.
Okay.
1,500 watts, 1,800 watts max. So whenever you're plugged into that, I can draw about 900 watts of energy off the grid, and it's very slow charging, but it certainly does it. And overnight, it usually tops off that way anyway.
So if you're in a pinch and you're at someone's house, you could plug into their
Absolutely.
their
If
wall
you're
or
looking, if you're doing opportunistically, you do it wherever you can, and that just
Opportunistically.
I literally do that.
I just find it
If
funny.
while I'm there, plug in 110. It's not much, but hey, it's just another de-stressing the
Where's power?
cells.
Where's power?
Yeah, so
Just
that
constantly looking
quickly
around
becomes
for-
Need a
one of
fix.
your focuses
Leaching.
is where your power is. That's a very easy leap to make. It turns out. So that's level 1, just that 110. So level 2 is basically 220 base systems, and these are really now in the public world. They're the normal charging stations that you see downtown and places.
Yeah, parking garages.
And they have a J1772 head. That's the standard name, the SAE standard.
Okay. I was going to ask about that too.
And so it doesn't really mean much to most people, but that's the little kind of curvy head. That's a nice little handheld socket plug unit.
Yeah, it kind of replicates a gas pump. Almost,
Yep,
right?
kind of replicates a gas pump.
Are all of the manufacturers using these standardized charging connectors? Right.
Yes,
So they've all
absolutely.
agreed it'd be stupid to try and do some
That's
proprietary
right.
thing.
The SAE 1772 is the world standard right now. There are some exceptions, and the fast charging are the exceptions. Now,
Manufactured by Sony.
well, it's funny you mention that because a Japanese company started this one called CHAdeMO. It's kind of a long acronym of some stuff, but it's really a fast charger, and it's a level 3, and it's a DC charger. It's putting out current right into your pack. No AC to then DC back to your DC pack inside your
So
car.
it's a dump, huh?
It's a fast dump, and in the handshake in the pod when you plug in, you handshake and say, "Give me 100 amps at 350 volts." Well, the voltage doesn't matter. It just says, "Give me 100 amps." It doesn't matter what the voltage
a current
is.
source, huh?
It's purely a current source.
Wow.
And it'll deliver
Nice.
100 amps.
Killer.
And so while the car is sitting there sucking up this 100 amps, and the pack voltage is going up pretty rapidly here, and as you know, when you have that kind of current going in, then you're pushing up to your maximum voltage earlier than you would if you were trickling it in, of course, and that's why you can only go to the 80% point during a fast charge. Well, it turns out that your BMS is part of this equation, and it's looking at all the cells. In fact, it's looking at every single one of them individually, and the one that is the closest to your top limit is the one that's setting the pace. And
So it's the weakest link thing.
you got it. Exactly.
Yeah.
So that very first one, it hits that certain threshold, predetermined threshold. Nothing bad about that. That's expected. And, it could be they're twinkling into that point, right? And then as soon as they do that, well, then you do a combination of knocking that current request down. Okay, instead of giving me 100, give me 80. And at the same time, you could even start shunting on that cell if you so desire.
I was going to
and keep the
say,
current
can
going.
you can the battery management system detect that? Oh, this cell is really dragging down the pack. We've got 200 cells here. We're not going to
Absolutely.
let's piss
Come
this
on,
cell
buddy.
off, short it out.
Yeah, so a better way to look at
Right.
it, rather than dragging down the pack, it's either it's charging up faster than the others and then discharging faster than the others. It's a weaker link per se, all right? So imagine that all the voltages are going up together, and individually they're all being looked at, and one of them is going up faster than the others, and you gotta prevent them from going up above a certain threshold. So the first one hits that point. There's nothing that says that you can't start shunting that right now, even though you've got a lot more current coming in than you can even shunt. But it's a relative thing. It slows that one down, and the other ones are getting caught up. It's all a relative thing on balance. And so now as you continue up, and your shunting isn't going to keep it held down, and it's still going up, well, at the same time, you're dialing down the current demand from this big charger, and you can do it smoothly and draw it down on a curve that holds the voltage at a fixed point, and it's all part of your battery management seamlessly working together with the vehicle control unit, the guy in the middle that's doing that work. In other words, it's telling that big charger what to deliver. The charger's doesn't have any brains. It doesn't know anything other than just it does what it's told. Give me this many amps. Okay, there you go. And so internally, the car is just saying, I can handle 80 amps right now, and the voltage is good, and I'm just starting to shunt on that. And it's like, oh, okay, that just stepped over a line. Okay, give me 60 amps, whatever step size you want, whatever. It's just completely whatever you want to do.
So the BMU is the master, really.
It's the
in that
master,
case.
and it's deciding what to do with your battery management and the source of power.
Nice.
So you said you could get 80% charge on a 90-mile range car in 15 minutes.
It
Is that
doesn't even
right?
matter what the range is. It's 80% in 15, 20 minutes. It doesn't matter because the current is a wide range.
Oh,
and
okay.
the
And you're saying
voltage
that the impedance is based.
the voltage is ignored. It has to be within a certain range, of course. As long as your pack is within the usable range of this system, then you just simply ask for current.
Wow, that's crazy.
Now, we need to get on to some questions, I think.
One last little thing to finish that, if you don't mind me slipping in. It just occurred to me, the part of the impedance, the lower you get that, then the more you can fast charge without the undue wear on the battery pack. And so this is what that breakthrough here recently, which is now all being put into production, these days, and it'll be coming out in the next generation here, this year and next year. Those will be taking advantage of that low thermal rise then in the cells and be able to then fast charge without any concerns.
Nice. Now, we've got our amp hour capacity is up, but as with guests, we always go over because it's so interesting. So we've got a whole bunch of questions from listeners.
Okay.
And I'll selfishly start out with one of my own. So we need some quick answers here. Otherwise, this will be like a 3-hour episode.
Okay.
What do you think about the government subsidies for the current crop of electric?
Really, that's the one you started
cars?
with,
I mean,
Dave?
there's so many people who
You started with
complain
that one,
about
Dave.
them,
You go into politics, the first one you pick
I've heard people complain about those, and I have a really good argument. And in this case, I think this is one of those things the government should be doing, strategic investment for helping aid the natural economy take over.
I agree.
This is one of those cases that would be a perfect thing to do. The people right now that are complaining about that tiny, tiny little blip in their pocketbook, because it's such a small percentage of the American population, it doesn't even register on in any one household, really. Comparatively to the very heavy subsidies that we have on fuel that I'm still stuck paying regardless, and that is very, very lopsided. So I think the argument is that we should have far more subsidies, and the naysayers should stop belly aching, because after all, that is how they got the stuff they've got, was with those techniques.
Yep. You can say the same thing about funding NASA, but let's not do it.
Okay.
Yeah, that's kind of with another kind of a longer shot between, the real world, but, it's still a good thing for technology.
But it's vital to the future of the industry, the
Yes,
future
it is.
of,
Absolutely.
the community, everything.
That's right. It's kind of the top of the heap for technology, and then the next level down, then we do, to get it to our world.
Yes.
Yep.
Yeah. The funding, it doesn't sound like it's a good idea to fund it, but it is. It just has to be done.
It turns out it is in the big scheme of things. Yes.
In the long term.
Yep.
Okay. Next. We got another question, Chris?
I thought we were going with all your questions, Dave.
I'm through mine. I'm
actually,
done.
someone asked
that
about
was his
the
first key project.
Someone asked about CAN bus, but I had a more general question just about how are you doing that with buses on coming back from the battery charge system? Is that bus based, or is that point to point?
Yes, it's all bus based, and it is CAN bus. Absolutely, Everything's CAN bus.
Right.
So everything very modularized. So the battery packs, they have a little 4-wire, nice little latching CAN bus connector. In and out. If you're daisy chaining them up, there's an in and an out, and then big fat wires that come off them deliver power to the drive system. But otherwise, no other wires going in or out of those things. Same with the charger. Same with the inverters that drive one or more wheels with one or more inverters. Everything basically centralized to the VC that talks to everything in a very succinct CAN communication.
Also, I was wondering, could you tell us some more about the range extender? You mentioned earlier before the show started about this new thing you've come out with, and so the range extender and kind of how that's affecting your company.
Yeah, first thing I should point out is that we just put a picture up on the website. If you go to, I think the eCar 46 page, right at the top of that page is a fresh picture of that got put in yesterday. And this range extender is actually a package that was intended to be as small physically in volume and weight as possible, so that you can justify carrying it around everywhere you go in an otherwise pure electric vehicle. The penalty then is minimal, and it gives me the ability to drive beyond my battery electric range. So this particular implementation is a 25 kilowatt design based on the fact that my BMW draws 16 kilowatts to 60 miles an hour, a level highway speed. And so I figured I'm going to put in some extra capacity in there so I could cruise at 75 or 80 or climb really, really long grades, etc. And have a pulse width modulation sort of thing where it runs steady state at a fixed single RPM point or off, one of those two conditions, but nothing in between generally. And what we found is that if we run this, in this case, a Wankel rotary, a single Wankel rotary, 294cc at a specific RPM point, very high RPM, there's a very good fuel efficiency point that happens in this design that then also benefits the energy transfer of power. RPM and energy transfer go hand in hand with small form factor. So the faster you spin a particular thing, the more power you can deliver. And so what we did is we designed a fairly small physical size package and then spin it at a high RPM and get power to weight ratio that way. So I basically added less than 50 pounds of weight to this vehicle to carry around this range extender that allows me to drive on fuel just like a regular car does. So this is
how much extra range can you get?
Well, so I have a 3-gallon gas tank in it now.
Yep.
And that 3 gallons will get me about 100 miles. Right now I've calculated driving with a 25 kilowatt load on this engine off of its specs. It's a very specific, it's a SPC I have a curve date of this. So at a particular RPM, I get a specific number. I've gone through the calculations and it comes down to 34 miles per gallon when it's at a steady state 25 kilowatt load. There's no variability to it. It's just humming at that particular speed and load, and I'm actually controlling this, believe it or not, without an inverter involved. I wound this motor specifically to match the battery pack voltage at that RPM point matched to that engine, and at that spot magically current starts flowing, and the RPM flies up to that point as if there's no load, and then as soon as the voltage matches, boom, it's like it hits a brick wall and it can't spin any faster, and now all the power pours into the pack. And I regulate that with a simple controller and a closed loop, and it just seamlessly pours power right into the pack in a high-frequency DC way that has no serious electronics involved. And so I just last weekend had it fired up and captured the data with my tech scope equipment, my big current probes and equipment and statistics, and came out with the result, and it's all working. With one minor exception, the winding ratio is off, so I'm running at half the RPM I should be right now. But for that, other than that, so I'm only delivering 10 kilowatts of power right now. But for that
Rounding
RPM
errors,
point, that is exactly what I should be delivering. And as a system, it's proving out. It's all there, and it's all self-contained. Well, an interesting part about this design is that it's literally in a suitcase-sized compartment that's sealed tight. And when I say sealed tight, I mean it. The floor of the trunk is really an airtight seal to this now little housed package that fills what used to be the spare wheel. And there's actually an air compressor in there, or I should say an air blower that pressurizes this to a static pressure that forces all the exit air past the header through a little shrouded sheet metal liquid cooled shroud that the exit air is pushing the superheated air off of the actual surface of the header, but then outside of that it's sealed to the exit hole out of this cavity and forcing all the exit air to go past the header, but then also liquid cooling that shroud as well as part of this whole cooling system. So the motor, the generator is liquid cooled. Of course, it's internally oil pumped and simply self pumps its oil fluid through a little oil to water heat exchanger that the first water passes through, the coldest water comes through, and then it goes right into the heat shield around the header, and then into the engine, and then back up to the front again.
It sounds like you're flying to the moon.
It kind of does. And then you take that. Well, there's actually heat being generated with that fluid going back up and sharing that resource with the radiator resource with the liquid cooled electric drive system, right? Well, I actually seamlessly work together two systems sharing that now. Well, then in winter, I want heat. I don't even have to bother then having heaters, the heat run. Because I do have electric heat right now, and it uses a high voltage water heater system.
That's very inefficient.
Well, it's relatively inefficient, but it's
not complicated.
It's not complicated, and it works. I plumb it right into the original heater core, and everything inside works just like it always did. So it was easy. But now I can actually get the heat energy off of these lines that are passing right by the heat exchanger of that system that's already there. So I put in one more little heat exchanger, and then I have another little opportunity in the winter that when the ranging center is running, you have full cabin heat from that waste source instead of from the electricity side.
Nice. Now we have a question from Raz PL.
Okay.
He's saying, you resell industrial motors and battery packs. What makes you think there will be a place for you when China starts pumping out their own controllers at 1/10 the price?
Yeah. Okay. Well, good question, and we've already thought of that. It turns out. Because it will happen. It's just a fact of life, and
of course.
And that's actually, in one way, that's really good. I can't wait for that. The economy of scale. That's what that's all about, right? Well,
although there'll be a dubious quality, though.
Okay, that's true, but
as much of the stuff is.
That's right, but nonetheless, they're still ramping up the core resource demand for the stuff that we're putting into higher quality stuff. So there's still some good stuff there. The way that we're working is that we're always one step ahead. We're not even talking about right now what the next stuff in the pipe is. And it's a whole new generation that is very much like what it is that we have right now being CNC'd and in the car and driving around and all this stuff. So we're always one generation ahead. So that's the answer in my mind.
That's the classic way of staying ahead of Chinese
GM or something back in the day, right?
And that's kind of why it doesn't matter. That's the answer to why it doesn't really matter that much.
Yeah, those people who complain about the Chinese undercutting them, be it on their kit or their product or whatever it is, they don't get it. They don't get that you have to continue to innovate to keep your market. You can't just
rest on your laurels.
Back on your laurels.
That's right.
Yeah.
And to be honest, I don't mind if their country has so many people that are demanding so much energy right now. I just assume them get as much of this technology as they can, and go to town with it in their own country, with their own quality. Let them deal with that. I think it's still a better result than what they've got right now for our sake. And again, it's a big world. They're not competing in our markets really, so I'm not even worried about the Chinese. Some people are. Obviously you have to make money, and to get this into the broad public, somebody's got to make money that gets it down to the level that's affordable, and ultimately American companies are partnering with the Chinese and putting the American quality with it, and so it'll eventually come here, but filtered through U.S. Partners, et cetera, and ultimately keep the cost down. I mean, that's kind of some of what happened to the solar industry, and sadly that pushed the U.S. solar industry down in a bad way.
Right.
But, I mean...
Same here in Australia.
Yes, and so there's some ups and downs to all this, but, that's just kind of life, right? I mean, we just have to...
That's right.
And so, rather than fight it and worry about it, just embrace it and go for it and let them go to town on this stuff. And I would just give them inspiration. We're just not really making it really easy for them and handing a recipe per se.
Right. Of course.
But make them work for it a little bit, and then given time, they'll get it turned on, and then we're already spitting out the next generation. So, yeah, it's all good.
With your company specifically, like, what about the, where are you selling into? Are you selling mostly the conversions? You kind of alluded to at the beginning that you might eventually start doing the rest of the car as well, or is it only going to be conversions forever?
Well, we started off with the idea of conversions because that's what I did, and it turned out so spectacular, gone beyond my expectations even, that this is something that's just begging to be a product. However, it is a bit problematic with the real life price of things, as you know, high end cost and low volumes, of course, is a recipe for just not going into a market, and that's just the way it is. So, we have to be realistic about this, and we would certainly do it for anybody that's willing to outlay about 70 or so grand to do so.
Right, on top
it's
of the
not
price
really
of the car.
economically proper to do it. Yeah. Now, on the other hand, the technology that we're continually working on and developing and testing in there, it's more than worth its weight in gold.
Yeah.
That machine itself, that design and stuff. But really, what we're doing right now is we're working with specific clients on specific projects that are conversions for their business that aren't necessarily made public, and put on our website per se. There are some pictures on a Facebook link now that shows some of the guts of this recent 4-wheel drive project we're working on for a client. Can't get too specific about it, but
okay.
it's going to be. We'll have a lot more popping out on the website in terms of videos showing the end result here within a couple of months. That you'll be able to see what it is, and it's like it's even funner project than my BMW was in some ways. Because of the performance and the fact that it involves dirt and 4-wheel drive and long travel suspension and so yeah, this is we're stepping into kind of a new world there with 4 individual motors driving individual gear reductions to each wheel. And the game
is
changes.
that a better way to go
make donuts.
than the one motor with the drive shaft and the everything else?
Well, there is
if
a
you're
lot
making
of benefits.
if you're making a car from scratch and you had what is the best choice? Is it individual motors, hub motors, aren't they?
Well, I stopped just sort of saying
wheel.
that part. It's individual motors is the top-down way to do it, except not necessarily hub motors. I wouldn't put them in the wheel, but inboard, of course.
Yeah.
So I mean that's a certain distinction, but absolutely as close as you can get to the wheel, but properly, on the sprung side. And so, that's the distinction there. But, ultimately that solves a lot of losses in a drive system. The differential is a very, very lossy element. There's no question about it. But you've got to have it. You really have to have it. Okay, this is one really good and clean way to get around it. In fact, a lot of other benefits just come flowing like a river out of this once you make the leap to this individual control.
Yes, the advantages are there.
Yep.
We've got a question from DICSEE. He wants to know about the process of how hard is it to get a converted car road legal. I guess that depends on the country, the state, the local
a little bit,
laws.
but it's actually he's overthinking
Don't
it.
tell
It's
anyone.
not hard. You start with one that's legal, and it's still legal.
Oh, nice.
Oh, okay, really?
Yeah, that's what I did. In fact, I explicitly went into DMV. And I went in without my DEQ sticker because I have nothing to burn gas, in it. And so I went to him and said I'm here to get my license, renew my license for this. And so, it's electric, no problem. Stamp and there it goes, so
okay. I don't think that's the case here. I think you have to get it approved by an engineer, and an automotive engineer has to sign off on it. Is that
only if it has to do with certain things? If it's a drive system that doesn't involve like brakes or or suspension,
there goes the 4 individual
things.
hub motors, right? I mean, then then you got to get recertified.
That's right.
Yeah.
So really, this BMW is still completely a full performance BMW in every way, shape, or form. And anybody could look at this and see the gas engine was pulled out and this drive system put back in, but they would agree there's nothing really different about it fundamentally in terms of the safety of it or anybody around me.
It's all
So an important part of this conversion, by the way, was not losing the ABS.
Oh yeah,
it's a very important thing to keep.
The hills in Oregon as well. Right? With the hills in Oregon, you definitely want that.
Oh yeah, absolutely. And so that's just another piece of this whole thing. Looking at the big scheme of things.
More questions. We've got to fire these off because we're running out of time. He also asked about have you heard about what about compressed air cars and other technology like that, like the Tata Indian car and stuff like that?
Okay.
What's your opinion? What's your quick opinion on that?
Absolutely. It's an interesting concept, but that would be a neighborhood kind of car only. It's practically speaking much more problematic than other forms of powering the cars. And yeah, air is free, but so are electrons. You have to actually do something with it that takes energy.
Exactly.
So there's really nothing free about it, and it's actually a problem about charging. It's a difficulty in your recharge time, even more so, and you can't really do a fast charge on those without some sort of an infrastructure.
And I think it's very dangerous too.
It is. It has an inherent danger to it just purely from pressure, but that can be overcome with a properly made tank and embedded. But that doesn't really buy you much in terms of range unless you go to a really exotic and expensive, safe way of storing that
and
pressure.
They are making this in India, so
and so it's an interesting concept, but practically speaking, it's a neighborhood kind of level machine only, and probably never see the light of day.
Yeah.
Interesting.
Got it. Well, another question from Lightbright32. Is it possible to recharge the batteries off the flyback from the motor coils? Is
no.
it worth it? Can you do it? And is it worth it?
Nope, you can't do it. There's really no energy. There's magnetic energy on the flyback for sure, but it's not wasted by any means. Every electron going in is accounted for. None of it's just wasted. If it were, it would be creating heat and just be going out as heat. But we only have 2% loss in our electronics in the drive system. So really, the motor itself, its loss is about 5%. Maybe 5.5% in the bulk of the operating range, and it's not something that you can recover and put back into the system and reuse. So it's not really practical. It's really something that's theoretically there, but it's not really wasted. It turns out.
And you do have recovery in this car, right?
Oh, absolutely. We have full regenerative braking.
Right.
So torque either direction is really just a minus sign in software.
Nice.
Either torque is in or out. It's one and the same.
Make it sound so simple. It's
at the high level, it is. It's that simple. How much torque do you want, and which direction do you want it? I mean, that's really what the CAN bus delivers to an inverter.
Yeah.
That's driving a motor that's hooked up to a wheel.
Just don't get that sign mixed up, right? If you
that's
have a
right.
bit error, you're screwed.
Assuming you've shaken it out and you have it right to start with, and then it won't change accidentally in the background.
Pull one of the Ferris Bueller where it goes off the back, out the glass window, and everything. And
yeah, well, that so in your first test, don't do it next to glass.
Yeah, right.
So how do you integrate all that into the existing ABS braking system and all that sort of jazz?
Well, it's interesting. I didn't integrate well, I guess I did. I seamlessly slipped in my drive system to their existing system. So imagine the ECU that used to run the engine. I consider that to be a subsystem, and that turns out to be the case. It was a subsystem that I just simply removed completely and then plugged my board right into the same slot with that dimension and used that slot and resources.
Nice.
In fact, so the plugs that went to the chassis I/O, I literally wired my board for that header and plugged it right into my stuff instead. So the brakes now, it's a separate subsystem. It's one of the many subsystems. There's the HVAC is another subsystem. The lighting is a subsystem. The locks and windows are another subsystem. So the brakes are a completely independent thing that are self-contained for liability purposes.
Yeah.
So if you have something go wrong with your gas engine and it dies and you're on the freeway, everything else still works. In fact, it's funny because I proved that. I went down the freeway, blasted up to about 80 miles an hour on the top of a hill as I was coming home one day before I converted this BMW. And I shut it off, and then I just checked everything. It's like, yeah, everything's still working. It has to. They're not going to have something that doesn't start to work if your engine dies on you,
Yeah.
And so,
That's right.
but I had to prove it to myself. But no, really, it's so system oriented that everything's a subsystem. The ABS is a self-contained thing with its own hardware, own electronics, and it just reports to the instrument cluster with a CAN interface, it turns out, in the BMW.
Did you have to spoof anything, or did you have to have any knowledge of the BMW communication protocol? Or
No, I didn't have to spoof anything. Now, if I want to use the gauges on the dash, then I would. And it's really easy to do. I just simply tap into the CAN bus, look at the data going by, you capture it, and you decode it, and you say, oh, that value is the gas gauge. And then I can then drive it with that same address and put the gas gauge needle to where I want. I haven't done that because I embedded my own digital display, an eVision system from Metric Mind, right into the instrument controller of all things that I embedded where the tachometer used to be.
And it probably looks so much cooler anyways, right?
It's all flush and embedded, just like BMW would have done, although the colors aren't perfect, but, I have more stuff to do with my time these days than to adjust that.
All right, one final question, because we've done an hour and a half. Woohoo! Epic episode. Where do you see the point on the graph where electric cars sales kick in and they overtake petrol-driven cars? And this can include not fully
hybrids and everything else,
electric cars, but it can include the Chevy Volt.
Yeah, I see.
Kind of thing. Where do you rough? I know it's impossible to, but
my gut feeling says is that the exposure and the reputation of electric vehicles will be increasing non-linearly over the next decade. And by that, there's going to be more people that know somebody that has one, and they hear that it's actually worked.
Yeah.
Okay, so this first so many years it has to happen with small quantities to help the big bubble of people make the leap.
The whisper factor,
so
right?
It's all the exposure, and so I mean, short of, let's say, an unexpected thing like a really bad event with batteries that gets blamed on that, for example. I see it kind of nonlinear, and by that I mean, people have these preconceived notions right now, and the bulk of the public do not have the details of this kind of stuff to even have the first iota of really any of these topics, and so it's so much an unknown they tend to avoid it. But as it's unavoidable more and more by neighbors and friends that have them, and then they start talking about them, it becomes more obvious that it's maturing, it's actually not risky, it solves a lot of other problems. You can drive with your own power if you want, you can go off grid and still, there's so many other things that come out of this, but right now all that stuff is overwhelming to people and they can't soak it up. It takes time and years. So I'm guessing, over the next decade, it's where we're going to start getting to where we're no longer just a fraction of a percent. And okay, when it hits the 10% point, I'd say that's where it kind of goes big time, and that's probably between 5 and 10 years. In my estimation, just trying to be realistic and practical with the way markets go and
battery technologies,
how finicky things are, and technologies, and the price of things. But the momentum on battery development right now and motor development are clearly a crucial underlying part of that equation, and that is happening in mass right now. Let me tell you. So that's the bright side. There's just really a lot of good stuff going on right now. I mean, I'm one of many doing this to this level, and I've been keeping a really keen eye out for battery technology improvements and motor details, and working with a direct motor design company down in California, where we're looking at this next generation to pull 2x more power out for the same weight. So here we're going to get power densities that are going to far surpass the gas stuff. It's just, there's so many things that are going to end up enhancing the ability of an electric machine to perform every bit of what the American public needs for transportation, that it's bound to happen, regardless what the naysayers think right now.
Yep. Well, I'd like to think my little boy at the moment is 15 months old. I like to think when he's going to be buying his first car in 15, 20, 18, 20 years' time or something like that, I think that it's almost inevitable that the logical choice will be at
hover
least it will be some form of electric car.
Absolutely.
Be it the Chevy Volt style combined gas
absolutely.
Range. I think I can't see him actually buying just a petrol only car in 20 years.
Absolutely,
time.
I agree.
I
think the petrol only type of regular transportation cars, I think it's going to drop below 50%. In that zone within your.
I think they're in their last decade or last 15 years.
Yep, absolutely.
20 tops.
Absolutely.
Absolutely.
I agree, and it's my evidence to me is the sheer power density, the longevity, it's the whole package.
Yeah.
And the life of the batteries is certainly part of it. Well, already the generation that I'm working with, which was already last generation stuff, that is just working phenomenally right now. That says that we are ready, and there's already a generation behind that I haven't even put in here yet. So, your son's going to be driving on third or fourth generation drive systems and probably fifth generation batteries, by then.
Yeah.
Yep.
So, yeah, it's pretty
a
much a given in my mind.
The future is bright, and companies like Artisan who have bet the company on EVs,
and that's a guy that's not particularly an advocate or a global warming backing guy. He's a business guy that started that ball rolling, and he saw the opportunity like a really good businessman would if it's there. Mm-hmm. And so, I think that's a really good model. The fact that they made a commitment and jumped in deep. And, they didn't just jump in, actually. They've been looking at it for quite a while. They just got more public lately, They do have quite a history, it turns out. Decades worth of battery development that they've been secretly working in the background, because I think they've been seeing the longer vision before most of us have been thinking about this, to be honest.
Yeah.
So
nice. Bob Simpson, thank you very much.
You betcha.
It's been
my
awesome
pleasure.
Episode. We could talk for hours about this
I could go on all day and all these topics and just love it. As you can tell, I'm passionate about this, and I'm making a point by stepping into the performance world without compromise, and I aim to prove it before rather than just talk about it. I'm aiming to prove it. And so that's why I've been kind of low-key until we get these three things breaking out here by the end of this fall, these three different things. A Gen 2 motocross bike, which is going to set a new industry standard in that world, the four-wheel drive off-road machine, and the BMW with range extender, limitless electric machine. Those are going to kind of be my PR blitz here coming up that actually shows actual stuff and hard numbers. I've got all the data that backs up every one of these machines all the way along, starting with getting the power myself. Mm-hmm. So I'm trying to put the full picture to the whole thing, and don't leave out any holes. Any hole that's left there, chime in. I'll find an answer for it if I don't have one.
That's great. Bob, where can we find you, more about you and your company, in case people want to look you up?
On our website at evdrive.com is where really
that's an easy one.
It's an easy one. Yep.
And are you on Twitter?
We are, indeed. And Facebook as well.
Oh, yeah, Facebook has a lot of pictures, like you said.
There's a lot of pictures. Hey, Facebook.
Yeah, the Facebook has some fairly recent eye candy on there from this new little special project going in the background here. So that one's is going to be very, very fun project, and maybe we can have a follow-on, or at least you can point your readers to some videos here when we publish them here in a couple months.
Sweet. Thank you very much, Bob. Been awesome.
Well, we look forward to seeing more about this in the future.
Stay tuned. Yep.
All right. Great. Thanks so much.
All right. Thank you, guys.
See ya.